Really? Go for it, Ron.
Okay, we're going for it. Clicking on all kinds of things here. Here we go again, ladies and germs, or viruses. Episode Big 50. This is the 50th get together. Our continuing series of vlog podcasts for the Santa Barbara Astronomical Units, weekly online get together of our board, what I call our brain trust. It's called the SBAU Astro Hour. I'm Ron Heron, proud to not be in radio and morning anymore and hosting this program. We kick around every week, and we have for almost a year here, space news and launches and satellites and all kinds of probes, the night sky. This week, we're going to talk about, oh my God, the JWST. It's in place. James Webb, ready for duty, but it'll take a few months. We'll talk about that once we get the president on board. Asteroid Ceres is in Taurus. I just love the fact that every week we talk about Taurus. Something's in Taurus, which is my sign, bullheaded as I am. Draco the Dragon, couple of clusters. One's a double and the other's in Virgo. And what in the world is going to happen to the International Space Station, ISS? Its days are numbered. Plus, we have interactive galaxies that Jerry Wilson, our president, who has left us temporarily, but he will join us again. There's a shot on screen, ladies and gentlemen, on this Monday morning, the 7th of February, our 50th program of our incredible Santa Barbara Astronomical Unit, a monthly newsletter edited by Tom Whittemore. Will introduce you. There he is. Welcome back, president of the club, 4 years running, Jerry Wilson. Jerry?
Yes.
Are you here? Are you back
Yep,
with us?
I'm back.
Put your glasses
The
on.
crew is taking a early lunch break.
That's okay. You may be leaving us at any time. We'll use.
Oh no, I should be able to stay here.
Well, sometimes the bladder won't let us sit tight either, you know. Chuck will not be with us, our outreach coordinator. I don't know why he didn't put Pat as merchandise manager. She's on the board. His wife should sub for him. Maybe he's with him at the dentist. Tom Totten running the show up in the left corner of my screen. Tom, webmaster, technical wizard. We have also joining us incredible former with lots of memories, Westmont College science instructor named Tom Whittemore.
Thank you, Ron.
I call him Captain Sourdough, and he doesn't mind. Edits that newsletter. And we have Bruce Murdoch, whose wife is Bonnie, and Bruce is a stalwart, longtime member. Totten is married to Suzanne. Jerry Wilson married to Pat Forgy. They're all members of the club. We incidentally had our meeting last Friday night. A virtual get-together, lasted just a little more than an hour. And went well, gentlemen. I'm trying to remember exactly who I missed here. Tom Whittemore, I don't know if you were on board.
Right. I was not.
Okay. But we had Chuck and Pat McPartland. Tom Totten ran the program again. Pat Forgy joined us along with her husband. And Chrissy Cook talked about the kids. There he is. Chrissy's joining us now. And Dan Godinez, a young what the heck did I just see? Having a flashback. That was Chuck McPartland live or just a picture?
No, it's just a picture. He's having his teeth pulled right now.
I understand that, right. Dan Godinez, who used to be a member, I had not met, but he did an interesting little talk called Mysteries of the Cosmic Universe, and he's back in New Mexico. And hello, McPartlands. We also got a thumbs up after the fact email through Tom Totten from Brian and Morgan Green. And there's a picture of my brain scrambled.
Only part of it.
That's only part of it. Okay, Jerry, I gave some of the topics we're going to talk about, but I'd like to do some of your silly stuff because you do forward them to us, and maybe it gets a little lightness going. Tom Totten, you want to go to the lab assistant class? Can you call that up? This is one of the science humor cartoons Jerry Wilson forwards to us. That's not it.
Which one we're talking
Get back
about
to
here?
that and read that to you. I don't know what that is, but
Not that one.
there it is.
This one?
Yeah,
Okay.
we have the student ducking his head into the strange college classroom, and the mad scientist at the blackboard says to him, you want mechanical engineering? Down the hall, kid. This is maniacal engineering. And on the board, it says today's lesson, reanimation of body parts of cadavers. Should touch a nerve with Tom Whittemore from his days.
Yeah.
Can you go to Going My Way? We'll get these out of the way. There's a long one, but I want to speed it up here. Going My Way is a weirdo hippie with a backpack thumbing his ride from some passing unexplained aerial phenomena. That's what the Pentagon now calls UFOs. They're
now UAPs, huh?
UAPs. There they come. Yeah, that's the wrong kind of well, maybe that's give an example of what humans are like for those guys.
So is that character called Herman? Is that the name
Yeah,
of the
that's
character?
one of the Herman con. Yeah.
Oh, it is. All
It's
right.
down in the corner there, down in the right-hand corner.
Okay, but this comes from your secret website, Jerry Wilson, that we don't know about. Can we go to Neil the Healer? Because I like Neil deGrasse Tyson. There we go. Young patient in the hospital bed. The doctor says to his mom, who's standing nearby, so you don't have a will? Mom says, well, I thought this was a simple procedure, doctor. He replies, well, these are standard questions, ma'am. He continues, do you have a religious preference, young man? You'd like a priest, a pastor, a rabbi? Teen in the bed says, I'm not religious. Oh, but I would like an astrophysicist, please. Doc says, all right, we can do that. And suddenly Neil deGrasse Tyson appears bedside. We are the universe, he says, and the universe is in us. Say hallelujah. Kid says, I'm feeling stronger already. We're all chartered members of the First Class Church of Neil deGrasse Tyson.
Yeah.
Now,
His Star Talk Radio is a pretty good program on that you can get listen to. I think he has YouTubes it and talks to various people. It's a great program to listen to Neil. He's a pretty smart guy.
Yeah.
That's right. He was a
There's an
prodigy.
understatement.
He was a prodigy of who was the original
Carl
cosmonaut?
Sagan.
Carl Sagan.
And took over. I think Carl Sagan ran the same museum, the Astro part of New York Museum of Natural History or something.
Hayden Planetarium.
Is it Hayden? Do you want to do the sort of a situation? It's long, but I'll speed it up because there's a message there. All right. Couple of people are talking. One of them, I think, is the student. He says, Professor, that guy claims the Earth is only 6,000 years old. Professor goes, so just use your head, kid, and don't concern yourself with what other people think. But he says the fossils in the mountains were put there in a flood. Well, evidence suggests they were not. But hey, listen, kid, 1 million people can call the mountains of fiction if they want, yet it need not trouble you as you stand atop them. But Professor, he believes the silliest things. So the universe doesn't care what you believe. The wonderful thing about science is that it doesn't ask for your faith, it just asks for your eyes. But sir, he's a US Senator. Oh God, then yes, we do have a bit of a situation. Well, there's a message. Fundamentalism. Okay, we got through all the silly stuff. We recapped our meeting. Are we going to have a board meeting, gentlemen, this coming Saturday?
Yes, we'll have them at 4:30 in the afternoon on Saturday.
And then if Chuck were here, he would tell us about our scheduled first outdoor second Saturday of the month Star Party. When is that? In March?
In March, maybe.
Okay, so we'll have a March 4th, exactly 4 weeks away from last Friday.
The Omicron infection rate is coming down fairly steeply, so we have high hopes for March.
Yeah, we sure do, but there's a new subvariant of Omicron called BA2. Have you heard about that?
Yeah, but no one knows what it does yet, if anything.
Well,
How do we know that the people that come to our outreaches are fully vaccinated?
We don't,
Yeah, I
but they
know.
are fully masked.
We'll take a look
Well,
at the Super Bowl.
I have a friend that isn't vaccinated. He can figure out all the reasons that you shouldn't want to do it, and the latest is graphene oxide. But anyway, I looked up the statistics. If you're vaccinated, fully vaccinated with a booster, your chance of dying from an infection is 1/10 of a part in 100,000, 1 part in a million. Whereas if you're not vaccinated and you get COVID, your chance of dying is 68 parts in 100,000 or 680 parts per million.
Wow.
But there's a big message there, isn't there?
There is for people who listen to it and can understand it.
All right.
Those are the same people that believe the Earth's only 6,000 years old.
And it's flat.
This is literally a Darwinian period.
Yeah, it really is weird as all get out. Listen, let's go to the things that are kind of coming out of nowhere that are kind of like breaking news. Then we'll talk about James Webb. The space station. Apparently, NASA is telling Congress when they're going to bring it down, the ISS.
They've always had plans to bring it down. They weren't going to leave it up there forever. And apparently the Russian compartments up there have developed some kind of an air leak, which they're trying to track down. I think they got it, but it's controversial. So
You think it's from a micrometeorite?
No one knows what it's caused by. It could be a weld that's come undone with fatigue or something. So the Russians are very concerned about the lifetime of their capsule and the ISS in general. Biden has just signed an extension so that the thing can go up to 2030, and then they're going to deorbit what's left of it. They're going to take several parts of it off, several capsules and compartments, and those are going to remain in orbit. But the core section, the original part, will be they're going to fire the rockets on the Russian section and deorbit it in a pattern. It'll still have astronauts on board, at least in the initial stage, to make sure that they get in the right orbit. Then the astronauts will leave the space station, and then its orbit will be a decaying orbit, and they will return to Earth, and so will the ISS. There's an agreed on place internationally where the deorbited satellites are dumped, called Point Nemu, and it's in the South Atlantic Ocean between Chile.
Hopefully you won't have a cruise ship that goes through there like they did that interrupted the last launch.
It's actually the South Pacific.
Oh, you're right, South Pacific. Yeah, there's
that's Argentina. I mean, sorry,
Chile,
no, the big white thing is the
Antarctica.
Antarctica, right?
And you can also see up at the top. Could you put the picture back, Tom?
Sure.
South part of the globe.
Yeah, you can also, up at the top right, you can also see New Zealand up there.
Wow.
So this is the target zone. If you want, you can sail out there in your own private yacht and try and catch a picture of the splash.
As long as it doesn't hit you.
Wow. Point Nemo, is it an island?
No, it's not anything. It's just a deep part of the ocean.
Nemo was the name of the captain for was it?
Nautilus.
Yeah,
Right.
Jules Verne's 20,000 Leagues Under the Ocean.
Right. The word means no one in Latin.
Okay.
Interesting.
Also the name
What
of
does it mean in Latin?
No one.
Oh, okay.
Really?
Mhm.
It's also the name of a cartoon fish in a Disney movie.
That's true.
Finding Nemo. We're going to have to find, that's a lot of hardware to come down, but they're going to take it all apart.
So the charter of NASA is to do groundbreaking research, like it is for all the national labs, Livermore, Sandia, all those places, and then hand it off to private industry. And so they felt they've done their duty and fulfilled their charter with the current space station. So they're going to deorbit the thing, and then private commercial firms will take it over. These firms are building new, more durable space stations, and several of the modules that stay in orbit up there will then be added to the new commercial space station. A couple of these space stations, the new ones, are also space hotels. So you can just go up there and stay for a while. As long as your hotel doesn't collide with another hotel, everybody's good.
Everything's going 17,000 miles an hour up there.
Yeah, otherwise they'd hit the earth.
34,000 miles an hour if they're two different things opposing each other.
Wow. And the Chinese one will stay up. I think they
Chinese
populated.
are the most ambitious. They're building their own thing. I don't know if you could call it a commercial one or not, because their economy is a controlled economy by the government. It's centralized, which we don't do. And at least not the way they do it. So they're going to build one that's something like 1 kilometer long. They're planning a really big one.
Huh. Do you suppose that Point Nemo is the bottom of one of their wide wavelengths that they go around the center of the Earth, don't they, pretty much? Did they go over Antarctica and the Arctic? I don't think they do they?
What do you mean? I don't know what you mean.
Well, the pictures we've always gotten way back in the early Apollo and Mercury and Gemini days was a wide
Oh yeah, the sine wave over the Earth.
sine wave over the middle, and it never went across the poles. So I'm wondering, is that how it orbits?
That is how it orbits, but this is going to be in a new orbit that's a purposely unstable orbit to do the reentry.
Wow.
Jerry, why does it look like a sine wave as it goes across the map?
Well, it's a circle around the Earth,
Up and down.
and it doesn't exactly repeat each time, but when you flatten it out on, what is it, a Mercator projection, then it gets that shape. It's largely around the equator, above and below the equator by 30 or 40 degrees or 50 degrees or something. So it never actually goes over
squash
the
sine
pole.
wave, isn't it?
What's that?
It's sort of a squashed sine wave. That's because of the Mercator projection.
Yeah.
But no, it's partly because it's launched from Canaveral. If it's launched from
Right.
Vandenberg, it goes polar, doesn't it?
Mhm.
Up and down. Interesting. Okay, but there's, even though they're going to separate the pieces of the space station, Jerry, it's all got to come down in various places. Is the earliest disconnect going to be somewhere else, or is it all coming down?
No, everything that is going to come down is going to come down there as one piece, I believe. There will be a lot of the modules, over the years, they added a lot of modules. And those things are going to detach, and they're going to remain in orbit. And some of them will be attached to new commercial ventures.
And just for the benefit of anybody watching this program that doesn't know, why don't they just let it land like a space capsule and collect it again?
Well,
More fuel.
yeah, the space station would need to have a heat shield on it to resist the heat. And since it doesn't, it's going to burn up. But I'm sure some of the pieces will reach the surface of the ocean,
Well,
at least as dust grains.
It'll be a flame and a half. It'll be one heck of a meteorite. Okay, that's breaking
Well,
news.
it's mostly hollow. You got to remember that. So,
Well, that's scary. I wouldn't want to be up there hearing there's a leak.
I wouldn't want to be the one that drives it into this decaying orbit and then jumps off at the last minute.
Especially when you have a malfunction.
Yeah.
But they got to fire some retro rockets, so at the last minute to slow it down and make it drop, right?
That's right.
That's how it's done. Okay. Can we talk about James Webb?
Sure.
It's being activated. It arrived a week ago at L2, from where it may very well observe the birth of the universe. They're aligning the mirrors. There's 18 of them, or 17 headed for the one in the middle. How does that work? Just out of curiosity. They're all honeycomb shaped. Gold plated.
Well, they're all hexagonal shaped.
Yeah.
Just so they don't have a lot of space between them. It's an efficient use of space. But there's 18 mirrors, and they're going right now. They're going through this 7-step alignment process that will take probably a month or two, or maybe more, to align each mirror.
Wow.
I watched a YouTube video on how they do that. I
Yeah,
now
it's really
understand it.
interesting.
Yeah.
First, they're gonna
Jerry,
the first image they're gonna get will be in the camera. They've already had first light. They've already shown looked at stars or a star, and the light has gone through the zoom, or through the you keep changing pictures and it keeps distracting me from.
Right.
So just stick with one picture, please.
Well, this is going to show you the steps, I think, as you talk about it.
No.
This is how they tested on Earth, was this
Yeah,
the
but
simulation.
Yeah.
And then they switched to actually showing the mirrors here in just a second. This is only 2 minutes long here.
What do they got? Little pressurizing
So they
mechanisms behind each segment that moves
yes.
micro-
They have several actuators behind each one. The thing is, what they're going to do is they've already got first light. Each mirror is roughly aligned so that it will produce an image of the star. So they get a pattern of 18 stars that is 18 images. And then they need to identify which of the 18 dots goes with which mirror. So there's a series of things where you move a mirror and then you look at the dot, which dot moved. And so you can identify which dot it is that is associated with each mirror. And that, then they go through several stages of that. That would be segment alignment. They eventually get down, they do from coarse to medium to fine alignment. The fine alignment is where they align the images up with, there's the 18 dots. They first align them up in sequence to give a central dot like that, but then they have to do fine alignments to make the mirror conform to a fraction of a wavelength, maybe an eighth of a wavelength less than the wavelength of, or 1/8 of the wavelength of the light coming in. So it's easier with an infrared telescope because the wavelengths they're looking at are between 10 and 20 microns, where the wavelength we look at when we work on our mirrors and we make them to 1/8 of a wavelength or 1/12 of a wavelength, the wavelength is 500 nanometers. So this one is 100 times, 10 times more, 20 times more efficient or more easier to do. It's a bigger number to hit. So eventually, when they get through with the fine tuning, it will be single spot produced by all the mirrors, and all the mirrors will be in phase. They call these segment identification, which is the first step, then segment alignment. Then they do image stacking, which is making sure that they all produce one image. Then there's coarse phasing, fine phasing, and then finally telescope alignment. And then they iterate the alignment for final correction, and then they get the thing functioning as a high performance mirror.
The little dot you're talking about is a star called HD 84406 in Ursa Major. Is that
No, that's the first science target.
Oh,
yeah, sure.
Oh,
yeah, that's the first science target.
This
one, they're just picking a star to look at to do the alignment on. By the way, HD 84406 is a star that's visible to us through binoculars. I've marked it with a cursor here in the Ursa Major.
So you don't know the name or number of the star it's looking at now?
No.
We can't see it by the naked eye, but
I don't know, but I assume we could. The brighter the star, the better. And maybe it is HD 84406, but that's also going to be its first scientific target star. I don't know that they've identified the alignment star.
So Ron, can you see the big bear in this picture?
not really.
Ursa Major.
But I do know the Big Dipper is part of it. It's the tail, isn't it?
So you see the Big Dipper there.
There it is. You found it. It's right in the middle.
And then, but you see the nose of the bear is out here. He's got claws, his claws or legs out this way, and claws and legs here. I'm not sure about this, how they consider it as a third leg or.
So the way you explained it, Mr. President, it makes sense. It comes clear to me. If every one of those 18 segments of the mirror, all hexagonal shaped, has a little dot, that's that star. They're its own version of, looking at the star, and they want them to come together. Once they all come together and make a big star, then the whole thing is working.
Yeah.
Wow.
First, they got to identify which dot is being controlled by which mirror.
Yeah.
That's the first part.
Well, I wonder why it's that star. I mean, just curious, why not the North Star, Polaris?
Maybe it is.
I doubt it. They would have said so, I'm sure. The near infrared camera.
So Tim Crawford had a question about the ISS. It scooted in here. He said that Axiom, I guess that must be a company, will be building modules around the ISS until it's deorbited, but I don't understand the standalone designation they were referring to in the remainder of the story. Does anybody know what that means, the Axiom modules?
I think that's a company. It's one of the commercial vendors that's putting something up. I know SpaceX and Blue Horizon both have plans for putting space stations up.
But
So
actually
it's
not
modules for them.
Fascinating. Thank you, Tim. Should have had him on today in lieu of our outreach coordinator. So 3 months of testing, and we won't get the first pictures official until what, 5 months, about June?
Yeah, about May or June is when we'll get the first scientific picture. I'm sure we'll get some pictures of the intermediate alignment process too, with real stars, and then they'll probably identify which star they're using.
But in your notes, Mr. President, it said the data they're collecting now used by engineers at Ball Aerospace, Space Telescope Science Institute, and NASA's Goddard Space Flight Center. But that's not the ones that are going to be controlling what it's doing later on, is it? That's.
I don't know where the control is. I don't know. I think it's JPL, but I'm not sure.
Could be. Maybe our former vice president will be
Part of that?
Adrian. Maybe he'll be part of that. Wouldn't that be something with boy?
Yeah, it could be. Yeah.
Caltech next door. Great stuff. So every week. Is Chrissy Cook still on? She was on the screen earlier. Are you still with us?
Well,
That
that
was
was a
just a photo.
Right,
Oh, that was
from
just a
last
picture.
Friday.
I thought she came on. All right. From our meeting last week.
No, she's at work today.
Oh, that's true. And she loves to watch you. We can be seen on YouTube live, or I guess after the fact, right? These
Yep,
programs.
yep.
Number 50. Shall we go to series and work our way out to the clusters, gentlemen? Or you got anything more to say about?
No,
That's fascinating stuff. I got to tell you, it's got to be.
well, there is a nice picture here of a double cluster. And the picture I show is one that I took a while ago.
Is it?
Oh,
Yeah.
sure.
We also got one from Bruce. Bruce, did you
Yeah.
upload your picture of the double cluster?
Yes, the double cluster in my scopes, especially if I use the focal reducer and it occupies the majority of the visual field, is just stunning.
Yeah, it's a stunning object.
Well, it's in Perseus,
So-
the hero.
So Ron, this is Jerry's photo here.
That's two clusters.
Mhm.
Yeah, how far apart they are, 100 years,
Separated by about 100 light years.
but they're 7,000 years away from Earth, and they're up in Perseus, the hero. Stunning pair of open clusters. NGC 869 and NGC 884. I
Right.
don't understand this part. H, just the letter H, and Chi.
Yeah. Well, it's supposed to be a Greek letter H and Chi. Persei, yeah.
Wow. Okay,
I'm
roughly.
going to find Bruce's photo. See if I got that
Right.
here.
They're half a degree
put
apart
that?
in the sky. Wow. Chi is
Yeah,
east.
just like the moon. And they're visible in a reasonably dark sky. They're visible to the naked eye quite easily. With
Easily visible here in the backyard.
Do we know how many stars roughly are in each one of them?
more than 3.
Lots.
100.
No, I don't know how many.
But I mean, that would be like us and our local group of galaxies, wouldn't it? Are they orbiting each other? Just-
No,
No,
well,
they're too far apart.
Yeah,
Once in the foreground.
Huh. Wow, there it is.
That's Bruce's. Looks like the stars are a little elongated, Bruce.
Yeah, I
Yeah.
noticed. Well,
There's tracking error.
I was aligned, but I didn't have a star, lining on a star. What am I saying? Feedback.
So this
I think I was aligned
auto-guiding.
within
yeah. good
auto
photo.
guiding, right? I'm aligned within probably four minutes of arc.
Okay.
which
I like the
one?
blue color of the stars.
Blue or green, or is that something else later on? Which is high, which is H and which is Chi? Is that what they're called?
Yeah, but I don't know which one's which.
Right.
Okay.
You seldom hear that used to identify them. You often hear 869 and 884.
But old man Messier didn't get a chance to lock one of his M's on it, did
He
he?
didn't put it in his catalog.
Yeah, amazing.
They're
Well,
just-
we have-
In the picture, the lower one, in my picture, is the nearer one.
Okay.
Okay,
And,
Well,
and how far away are those clusters from us?
7,000 light years.
Oh, wow.
about 100 light years apart.
Yeah,
And
when
I got-
people look in my scope, my image is reversed from others because I have a roof prism diagonal, which doesn't flip the image left to right. It is what it is when you see it in the sky, like in a pair of binoculars.
A roof prism.
Yeah, it's a roof prism.
So Tim Crawford has questions about the clusters. He says one seems to have red giants, with the other does not seem to have any.
Yeah,
They're about the same distance. So why would one have red giants and the other not?
they just
They're
form
further
differently.
along in the revolutionary cycle.
Yeah,
He was guessing they.
Good eyes. You've seen that a lot with me through the 8-incher at Westmont. I know.
yeah.
It's a beautiful pair of clusters up there.
Now, the red giants in the lower cluster, they really stand out if you look at the cluster in a pre-dark sky, like in dusk, but it's not fully dark yet. There's still some sky glow. It makes for some reason, it makes the red stars really stand out.
Yeah. The one I will always point out, there's a pretty little necklace of stars in the cluster up above. You can say a little necklace. I often point that out to folks looking through the 8-inch at Westmont. It's very small, Tom. There's a little U up there, upper cluster. Go down right there. It's like a little necklace. It's really beautiful.
Are we looking at the total number of stars in those clusters? Literally, it's only a few dozen rather than hundreds or thousands.
You're looking
Our
at it.
eye can see a much wider range of luminance than can the camera.
Yeah.
So when you look at it with a telescope, you're going to see a lot more stars than you're going to see in a single exposure like this.
Yeah.
And with red
Yeah,
giants,
If you look at this pair in my homemade 18-inch, you have to wear sunglasses.
but with red giants, we could get a supernova conceivably someday. You never know. Right? Might jump the gun on Betelgeuse. Fascinating stuff. Can we go from there to the Virgo cluster?
Sure.
Largest cluster of the galaxies in the constellation of the same name, Virgo. The big cluster
That's a scandal.
part of the Virgo supercluster. M.
Now, this is a cluster of galaxies. It's not a
Right.
star cluster in our galaxy.
Right.
This is a cluster of galaxies. It's outside of our galaxy.
Oh, I see. Okay. Different animal.
Yeah, different animal completely. And
Yeah.
our galaxy is in a cluster, a subgroup called the local group, and it's part of the Virgo supercluster. This shows the Virgo supercluster, which contains the Virgo cluster to the right of center. This is centered on our galaxy, and that's called the local group.
Okay. Does it include Andromeda?
Yeah, Andromeda's in there.
Okay. And that's probably the furthest out and the biggest, wouldn't you say, of all the galaxies?
No,
Not the biggest?
no, the size is not indicated on here, but I think our galaxy is bigger than the Andromeda galaxy.
So the word supercluster means galaxies. Regular cluster, double cluster, things like that is in our galaxy, just stars.
Well, the word galactic cluster is galaxies and star cluster is stars.
Okay.
Whichever once you get the context fully established, of course, then you just switch to the word cluster and everybody knows what you mean, whether it's galactic or star.
Yeah.
And
Tim wants
What is
to
the angular
know.
subtens?
What's Tim want to know?
Tim wants to know if are there more galaxies visible in certain areas of our sky than others?
Yes.
Yes.
Yeah, they're dark
Or
holes.
really, if you had the Hubble Space Telescope, would you see the same number of galaxies across the sky if you could see all the way down?
Well, the reason we see galaxies more easily in some parts of the sky is because the Milky Way is not in the way. But if we were out if we were a star all by ourselves, not in a galaxy, then the only cluster that we would see would be these galaxy clusters. And I believe they're pretty uniformly distributed along their neural network-like veins that the universe is made up of.
Are we at the center of those crosshairs on the screen,
Yes.
or we are?
Yeah.
But they're not orbiting us.
No.
Okay.
And Tom, if you wouldn't mind.
They're
going back to
orbiting the great attractor, aren't they?
your previous image, the image of the Virgo cluster, was pretty nice. Not that. Okay. That's probably done from a pretty wide field telescope. You can see these things easily in an 8-inch. I see them easily. If you look over on the right, that's the smiley face I show people. See the smiley face? 1, 2 eyeballs, a nose, and a little mouth.
Oh, yeah.
I always show that to folks in my 8-inch.
Okay, gotcha. Thought you were talking about a lens thing, an Einstein arc.
No, it's just a little, you could call that an asterism if you want, except it's a galaxy.
Yeah, you could call it the Virgo triplet.
But
It's the smiley face, Jerry.
Yeah.
That's, easily visible in 8-inch. My 8-inch telescope's an f5. So I get a nice wide view of stuff.
Yeah.
what month of the year is Virgo?
You can see it now if you stay up.
That's not my question. It's on the ecliptic
It's often considered a springtime object, a constellation.
I think the Baron is talking more astrological. When is the sun in Virgo?
Well, there's
It turns
August.
out it's in August or September. Yeah.
Yeah.
so we're saying this supercluster is in one place rather than all around us.
Yeah. Yeah. It's a
Really?
collection of galaxies, Ron.
I thought they were everywhere. They were off to the
The
side.
galaxies are, but you see over there see the yellow label on that cluster of dots?
Yeah,
That's the Virgo cluster. And that's
Oh,
all roughly together.
Mm-hmm.
and those
and
are
then-
those are galaxies. They're not stars. They're
No, they're galaxies.
Those are galaxies.
Yeah. And these circles, these blue ellipses are not orbits. They just they're to showing the foreshortening of the plane that we're looking at. And these dotted lines that go from a point up there like this one for Dorado. See that down there, Dorado, and there's a dotted line that goes up. That shows the distance below this plane that it is. So it's trying to give you an impression of the three-dimensionalness, where these things are located in 3 dimensions. So the Eridanus cluster and the Fornax cluster down on the lower left, they're almost opposite from the Virgo cluster in relation to our galaxy. They're down and the other side.
Yeah. And the Grotto and Fornax and Eridanus, they're in the southern part of the sky.
Yeah.
Here.
What is the angular subtense of this whole image that you're showing?
Well, it's not a view that we can get from Earth, so I'm not sure it has an angle.
Oh, all right.
Depends on where you are. But Tom's pointing out the linear scale, 10 million light years. So this looks like it's about 200,000 light years from left edge to right edge.
Mm-hmm.
would it be?
So if I take 10 million, which is 10 to the 7th,
Yeah,
divide it by, what did you say, 200,000? 200 million light years.
200 million, yeah.
210 to the 6th. If I take the arctangent of that.
That local group they're showing, remember Andromeda is
It's
only like
2.9 degrees.
2.5 light years away from us. So Andromeda and Milky Way are pretty close to each other right in
Yeah.
that center there.
Yeah, they're not individually identified because they are so close to each other.
But all of these galaxies, including us, including Andromeda, are sort of defying the expansion of the universe thing. We're actually
Well,
gravitational.
not even close to it. If you look at the expanse of the universe, this whole diagram would be a very tiny dot.
Right.
Well, it'd be one of those part of the filaments that you see everywhere, filaments of galaxies. We just happen to be.
It's real fine. We'll show that next week. The whole the whole universe in how the galaxies are distributed. It's pretty cool. As a matter of fact, on last Friday, the guest speaker discussed that distribution and how it looks like certain biological forms and neural forms in its large structure.
But now, every so often they find these gigantic, huge, I guess they call them elliptical galaxies, which used to be like local groups. Probably we're going to become one someday. We're all going to merge together.
I don't know the evolution scheme of that. Unfortunately, I was been in this long enough that I remember Zwicky's classification of the evolution of galaxies, which is largely wrong, but I've got it fixed in my head. But I've also got a big caveat under it that this is to be determined. But if you scroll down, I have images of Messier 49 and Messier 86 that are part of the Virgo cluster. But and these are obvious elliptical galaxies. There's no structure. Go ahead, Tom.
Yeah. Oh, I was just going to mention that I think it is believed, though, that elliptical galaxies are cannibalistic and are the result of, gobbling up a lot of, stars and galaxies. Yeah. I still think that's on board. Okay. The ellipticals.
They're not spirals.
No.
Big
Tom, can you show M49 and M86?
Yeah. They're sometimes, Ron, called lenticular because they look like a little lentil.
I thought I was showing them.
Well, they're fascinating to me, I got to tell you.
Yeah, another thing I was just going to point out with that really beautiful image of the long string of galaxies in the Virgo cluster is that those are pretty bright, because Messier named a ton of them. Yeah. And he was using it like a 4-inch telescope in Paris before all the lights clobbered him.
I was going to say that.
So if you look at it's really fun to show folks. They're really fun to show folks.
Yeah, Jerry.
So these are galaxies. The one he just showed and this one are galaxies, and you don't see any spiral arms. You don't see any dust clouds in it.
Right.
These are just what's called spherical galaxies or irregular galaxies.
How does that differ from an elliptical galaxy?
Elliptical is the word I was looking for.
It is an elliptical. What the heck keeps all those stars from just collapsing in on each other? They're not organized in a.
They're orbiting. They're in orbit.
They are?
Same thing that causes the space station to not fall onto the Earth. They're in orbit. They have a sideways velocity.
Wow. Well, my understanding was that galaxies pass through each other, but occasionally I guess they catch each other and stay like that.
Yeah, they merge. There's a really beautiful pair called the antennae. The antennae galaxies. You can see how they're basically disrupting one another.
There, now stick with this one.
There you go.
That's a gorgeous shot.
This is two galaxies that have passed each other close enough that there's one of them is leaving a trail behind due to the gravitational pull of the other one. So these have interacted, possibly not a full collision, but their sharing stars have been disrupted from one, probably from the big one to the small one.
Yeah, and you can see the one on the right. There's a lot of blue outbursts there that tells me that in that passage, those galaxies have influenced starburst.
Yeah,
on another.
But you think they're going to go back together again?
Oh no, I don't think so.
It depends how fast they're going. They could, they could pass each other by and then loop back.
Yeah.
Okay. Wow.
It's really pretty.
I guess James Webb will see some of those early collisions, maybe far out there, 13, 14 billion miles away.
So what does ARC mean?
Oh, Halton C. Arp. It's the last name of a astronomer. Halton C. Arp. And he started a catalog of interacting or oddly shaped galaxies.
Right. He was looking, I think, at common redshift groups. So he knew that they were moving together, okay, and interacting, you know.
So is this ARP 87 that you mentioned in the closing notes, Jerry?
No, that's not
Yeah.
it.
Oh, okay. Not
It
in-
is. I think it is ARP 87, right?
Yeah, ARP.
Oh, I'm sorry. I thought you said M87.
No,
Never mind.
ARP. I was going to
Yeah,
ask about.
an ARP, yeah.
Also known as NGC 3808.
Yeah.
What is it?
If you could go to M87, we do have a picture of that there. Now this is another elliptical galaxy, and this is the one where they found the massive black hole at the center.
Right.
And you can see the jet that's coming out from the accretion disk on it.
Hey, Jerry, there's a woman, I think she's in one of the Texas groups, who actually saw that jet in a 20-incher. She's
Wow.
got eagle eyes.
I guess.
Wow. And yet that's only about 5 to 10% of the mass. The rest of it is dark and we can't even see it. The dark matter is even bigger than that.
Some galaxies, they have different proportions of dark matter. I recall two galaxies that were recently identified that have virtually zero dark matter in them.
Wow. How in the world?
I don't know.
That's an amazing shot.
Yeah.
I've never seen a jet in my 18. You know, even up at Lassen Volcanic Park. So.
But can I ask a question, Mr. President, back on the Virgo cluster before we let that go totally?
You just did.
Your Magellan,
You can ask two questions.
well, we're way out there now, but just the last thing that occurred to me is your Magellanic clouds, your triangulum, they're all part of this local group, but they're not part of the Virgo cluster. Is that a fair statement?
No.
They're not in it.
No.
Okay, interesting.
The local group is a subgroup of the Virgo supercluster.
Right.
So the local group and the Virgo cluster form, and some other clusters form the Virgo supercluster.
Right.
And that Virgo supercluster is what you see here in this picture.
Mm-hmm.
Obviously, there's probably other galaxies we cannot see because they're beyond the part we see of our galaxy, right? They're beyond the clouds in the center.
Yes, we keep finding new dwarf galaxies near us and other galaxies farther away by looking through our Milky Way star clouds. They're hard to pick out because there's so many stars that are not part of the galaxy. They're in our galaxy.
Wow.
I want to show. Can I show Bob Richards' view of M87 and the jet that he took?
Yeah.
I'd love to see that.
Go over that. Bob took one right here with the horizon camera that kind of just is additive and picking up light, and he picked up the little jet coming out of M87 on this one.
Pretty neat.
So maybe that's what the human eye might see in a 20-inch telescope, huh?
Yeah, well, this lady's just amazing eyes.
What are we looking at? A star or a cluster?
Oh, no,
M87.
What? I can't
It's
understand.
a big galaxy. That's the center of the M87 galaxy. That's really bright. Can't see the outer layers of it.
And it's in the local group?
But Bob Richard or Robert Richard, he picked up the jet coming out with his camera.
Oh, on the bottom.
So Ron, I think of 87 as kind of like the core of the Virgo cluster. So it's really bright, you know.
I think
but that jet is very, very tough to see. Really tough.
Wow. But there's stuff we'll never be able to see beyond our own galactic plane because that dust, even radio waves won't go that far.
There's
Will
stuff we're never going to see because of the expansion of the universe during the inflation section. You know, I mean, the universe in principle is over 90 billion light years across, but we can only see out to about 13 or so billion light years.
Well, I came up with a question that I'm not sure if I can ask it or not. Maybe this is the time. Your James Webb is
Mhm.
going to pick up the infrared part.
Yes.
Spectrum, right?
That's the big beauty of that scope, Ron.
Okay.
And because of the stretched information and expansion of the universe, it's going to look back to about 400 million years after the Big Bang. No scope's ever seen that far. Okay, and so we may be able to answer the question: did stars come first or galaxies come first? So it's I can hardly wait to see some of the stuff coming off that thing. It's going to be amazing.
But are there some galaxies out there so far away that you'll never be able to see them?
Yeah,
Light hasn't reached us.
What I meant is that we do not have enough time. There's not enough time that has elapsed for the information to come to us. Okay, that's what I meant.
In 96 billion years from now, we will be able to see the present edge of the universe. But of course, by then it will be much bigger and we won't see the
right.
Well,
The Earth is the universe is 13.8 billion years old.
Right.
But we can see back about 45 billion light years because of the expansion of the universe.
No, we can only see back in a radius of 13.5 billion, 13.5.
Right.
What we're seeing at 13.5 billion years is now about 45 billion light years away because of the expansion of space-time.
Yeah.
Well, inflation. Yeah, I would call it inflation on that.
Inflation,
Bruce.
right.
Yeah. Mm-hmm.
But the reason we need a radio telescope like the James Webb is that the light that emanated originally from those galaxies so far away has been stretched and gone down into the infrared spectrum. Here's my question. What about the upper areas of that spectrum, the electromagnetic spectrum, which are gamma rays coming from those same galaxies, gamma rays and X-rays? Would they have decreased and stretched down into the color spectrum? Do you understand my question?
Maybe not all the way to the colored spectrum, but they would also be lengthened.
Yeah, they're at the mercy of the expansion, Ron. It's all EM radiation. So
aren't they just above the color spectrum? Ultraviolet?
No. If you said gamma rays, extreme high energy, nuclear type, interactions.
Well, what's in between the color spectrum, which is infrared on one side, ultraviolet on the other? What's in between that whole spectrum in the middle and your big heavy duty gammas and X-rays? Is there?
Well, it goes up to ultraviolet and then far ultraviolet and then X-rays and then hard X-rays.
Right.
Okay, but
so Ron, as the sun basically burns hydrogen into helium, in that process, it's creating gamma rays, very high energy photons, okay, that basically come from that cook pot down the middle of the sun, okay?
right.
So, there are gamma rays in the sun, but by the time they get out to the photosphere, the part we see, they're visible. They become visible after a number of interactions with the soup, basically, that comprises the sun. And there, Tom's got a nice shot of the spectrum.
Well, they've sure tamed them in my dentist office. They don't even leave the room now.
Well, those are X-rays, Ron. If they hit you with gamma rays, you'd know.
Actually, you probably wouldn't know.
Gammas are the ultimate. Wow.
You see the gamma rays.
You have to put things in.
Yeah.
You have to put things in perspective. When you see all these plots, they're generally on logarithmic scale.
Right.
So visible light is like 10 to the 15th hertz, but the gamma rays are 10 to the 20th. So they're 5 orders of magnitude separated.
Right. Yeah. So it is deceptive, Bruce.
Yeah.
Well, it's fascinating to me. I love that old spectrum. I was going to say, if they disappear because they've gone so low, they've gone below the infrared spectrum, maybe we could listen on radio waves from these distant galaxies. But
I was going to ask you guys off the subject if we'd have just a little spot of time before we finish up today. I could just tell the folks about some fun binocular stuff I've been doing.
Sure. Go for it.
Well, I don't want to take you away from the subject, but just before we leave, I've just been having a lot of fun because the skies have just been so darn clear. Okay. And we have here at the house a spectacular view of the southern horizon So if you would let me just go for 1 second, it's kind of fun.
Okay,
and
with me, Mr. President.
It's up to, yeah, it's up to you guys.
Yes.
Is it okay?
Yeah, go for it.
Oh, okay. Okay. I was just going to say what I've been doing because it's been so beautifully clear lately. And Canopus is visible from the house, easily visible by about 8:30 or 9 o'clock. And by that time, Orion is high in the southern sky. It's way up there. Okay. And one thing I've been noticing with my binoculars, and again, these are really good bird binoculars, but they do an awfully good job at, at the night sky for astronomy. If you take a look at, and again, I'm talking about 8:30, maybe 9 o'clock in the evening, Orion is basically crossing the meridian. It's the highest it's going to be. And if you get its sword, if you get Orion's sword and you just follow it down, you go through Lepus the Hare. And with binoculars, it's just a lot of twinkling, beautiful stars there. I mean, Lepus the Hare only has about 6 major stars in it, but there's a lot of ancillary stars around them that are gorgeous. If you keep going further down to the south, but still obviously above the horizon, you get into Columba Noachi. So Columba's Noah's dove. Okay, and you see the sword there. Thanks, Tom. You see how the sword just points due down like that. So that sword, again, I'm not talking about the belt, the sword, and it goes right down through Lepus the Hare. And if you continue towards the south point, you get Columba Noachi, which is the dove that Noah let go to find, dry land, right? And in the flood story of the Bible. That basically the dry land became Mount Ararat, okay, which is not to be confused with Arafat. Okay, so. So I don't know, Tom, do you have a little thing of the dove? It's really just a really pretty triangle of stars. And there's a lot of nice stars. There's Columba, yeah, the dove. Okay. Other things people can do is take binoculars and go just to the left of Orion and down. Well, you'll pick up the big dog, Canis Major. And in binoculars, there are a number of nice little star clusters you can see, including one that Chuck calls the Pleiades, M41. Okay.
Is that thing off to the right, is that the constellation of the gear shift lever? Calum?
What's this, Jerry?
Go down where you were. Yeah, to the right.
Oh, yeah, Caleb.
Yeah, now that's the chisel.
That looks
really
like a gear shift lever.
Oh, for crying out.
Calum's the chisel.
Oh.
Yeah,
Looks like it got hit too hard.
Yeah.
4 by 4.
If it's COELUM, it means heaven. But CAELUM is a chisel. These are pretty far south, Jerry. Caleb.
You're kidding. Is that an Astrum or one of the 88?
This one, the 88?
Yeah.
The chisel?
Mm-hmm.
I've never seen that before in my life. I'm sorry.
It's in the southern sky.
Right.
Southern.
I'm not sure if we can see much of that constellation, Ron. Okay.
Pretty far south.
Yeah. We can see down to minus 53 right ascension. Minus 53 because we're at 37 degrees.
You mean declination.
I'm sorry, declination. Thank you, Jerry. Yeah.
Huh. Well, I got to tell you one thing. The advantage of binoculars over a telescope, you don't have to close an eye.
Yeah, it's just fun. And the sky, like I said, just been so nice and dark and beautiful, although the moon is now taking pieces out of it. Okay. We're coming up on first quarter pretty darn soon, but it's real high in the sky. So when you look to the south, you can pick up some pretty cool stuff. Okay.
I may have asked you this already, Whittemore. Maybe you answered. Yeah. Is there a lock on your binoculars that holds it steady?
No,
You just hold it. You can actually hold it without making things jiggle all over the place.
Oh, yeah. Well, these are just 8 by 42s, but they're really well made. They're basically bird binoculars I use, to look at birds, but they do an awfully good job at the night sky. I mean, I've got 9 by 63s, okay? And those are a little jumpy. I actually prefer my little bird binoculars. Okay.
Why do you suppose
we get binoculars today that have got image stabilization in them?
Sure. Yeah.
Why do you suppose they don't make telescopes with two viewers, two lenses?
You do. Oh,
You do.
You can get
They're
those.
called bino viewers.
Never seen one.
They're very expensive.
Very
I think
expensive.
Tom's
You
got
have to
one.
buy 2 eyepieces, Ron.
Is that right?
And if you're buying Nagler eyepieces, 2 of them is very expensive. Okay.
But it's looking at the same picture, the same mirror image, isn't it? To both eyes.
Yes.
You get
Yeah,
a three-dimensional view nonetheless. I mean,
Yeah.
it gets a pseudo three-dimensional view.
Right.
Really?
Yeah, it really does look 3D, Bruce. It really does.
My God.
Yeah.
Cotton, you are so awesome, I swear, but we run out of time. Look at this.
Oh. Okay. Yeah.
Well,
Oh,
gentlemen.
there you go. Binoculars.
Oh, look at
World's
that.
biggest binoculars.
All right, listen, we're gonna have to go away and come back in a week, and next week we'll have our business meeting. You're invited to jump on board. I guess a month away, we're gonna have Briley Lynn Lewis talk to us from UCLA, young graduate student. And just don't catch Omicron or its new subvariant BA2.
Yeah.
Gentlemen, thank you. Take care of your
Yeah.
wife.
And thanks, guys, for letting me pop in there. Just talk about who I
Yeah.
see.
Happy 50th. We got 2 more shows and we will have done a year.
All
And I've
right.
done everyone except one, which was thanks to the updates, but we'll see you next Monday morning on the SBAU Astro Hour. Both
right.
Toms,
All right.
Bruce, and
Thank you, Ron.